This is now our 9th session. Thank you all for joining us. Just as a quick review of what we've covered before the end of 2024, we covered the role of management leadership, some accounting, tech debt. We did org design, that was small, durable, autonomous teams, OKRs, and then really heavily in January, it's around architecture with the risk model, anti-patterns and patterns, our cubes. Today, we're going to cover principles. These are common principles most of you know, although there will be 2 or 3 that might be somewhat new. At the very least, it's a way for you to point your team to some common principles so they can operate more autonomously on their own. Next week, we'll do monitoring and operations. And in operations, we'll get into more about running your digital footprint across your team 24/7 by 365, just some tools, best practices. And then we'll shift into product and process management and a bit of portfolio management. And then into May, we'll get into big data, machine learning, and then transformations. We have been updating these on YouTube. So even last week's session, I believe, is in YouTube.
Correct.
We're also updating in YouTube the links to our blog posts that reference this. So if you don't want to skim through the whole YouTube video, you can see the top articles that reference these concepts. So it may be just a faster way to consume that. And then, Doug, correct me if I'm wrong, I think these do have our own closed caption, or is it just the default YouTube closed caption?
No closed caption on any of them yet. That's one of the things we've been experimenting with. I guess I would ask would closed captioning be helpful for you guys as you're watching those? It's an easy add for me, but it's not something that I've included yet.
So just waiting on the chat if any of you are interested in that. Very good. We've got at least one that would like it. One more item that just to mention, on our website, we have a feature called Ask AKF. So it's a much more robust version of our search engine. So it'll search through our blog posts and it'll provide a conversation back in more of a natural language approach. It's also indexing our books, particularly Scalability Rules and the Art of Scalability. And if the answer isn't from our blog post or those, it's doing an open search. It's just using, I believe, ChatGPT behind the scenes for other aspects. So feel free to check that out too. And you can get a quick answer versus skimming through our blog posts or even the YouTube. So hit it, but mark that too, please. Very good. So architecture principles, these are the core principles that you'll use just to really run your teams, run your business. It helps them make good decisions on their own, and a good one to reference back to those. We're going to show most of them here. You can take some of these and put them into your environment, but we're just going to hit a highlight of these. We're going to group some of these together. A lot of these will be things you've heard before, but again, just as a refresher reminder, some of these, as we mentioned, will be somewhat new. Recall from our conversations about 3 or 4 webinars ago that architecture decisions can improve cost effectiveness, they can improve scalability, they can improve availability, and sometimes they can do 2 of these, sometimes they can do all 3 of these. All of these principles here can help you, and we'll start in the top left, and they'll move down and around availability and scalability, and we'll hit most of these today. Again, some of it will be a refresher for some concepts, but just to reinforce it and some reminders. And some of these concepts do take a while to hear a few times and to embrace that. I think you saw that note there, Doug. You want to flag that one.
Good.
So how we use architecture principles at the very high level, the business owner, or this could be the CEO, the board, they create the measurable business objectives, referring back to the OKRs. These are the objectives or outcomes of what we want to do as a company, where we want to compete and win in the market, how we want to make a profit. Those are the objectives. Those in turn are used by the architecture team to create principles, and most of the principles we cover will apply for any business. You will just use some more than others based on your objectives. For example, if you're really focused on cost containment, you're going to emphasize some principles. If you're focused on rapid growth, acquiring customers, capturing market share, you might emphasize other principles. Those in turn are used by agile teams to make decisions by themselves or to inform, so they don't have to rely on that single architect to make all decisions for them. they can operate more autonomously. And in turn, they may have specific design principles that apply within their particular domain or team, whether it could be in an ML pipeline, it could be in a highly transactional system, it could be in an analytics system. Those principles may be emphasized a bit more within a particular team or domain. We're just going to reference back the risk model again. This is that busy one we built out. And so looking at it from what can go bad, something will break. It's going to have two aspects, the probability that it will have an incident and then the impact. On the left side, those are the components and call chains, the availability of the components, the component communications. And then on the right side is more around the impact, which is, can we reduce the blast radius through customers impacted or fault isolation architecture? Can we reduce the duration? The principles are, the primary principles here are architecture principles that apply to these elements of the risk model. Now, some of these impact multiple ones, but these are the primary principles. So release size, for example, just releasing small really decreases the probability of an incident. Testing, you want to have as much automated testing as possible. That's going to increase your quality, which will decrease the probability of an incident. So again, just is another way of looking at it from what can go bad, just from a pure availability perspective. We'll go into these in a bit more detail, but looking through our risk model, this is just another way to look back at these key principles. The first one, this is a common one, using mature technologies, things that you know work well. When you choose to buy something and you're going to buy something in your stack somewhere, you typically want to buy something proven. And why is that? Well, early adopters, if you want to be on the cutting edge, you're also going to find the bugs associated with that. So just looking at that graphically, this is the technology adoption curve or an S curve. This is something that many of you may have seen before. On the y-axis is performance, and over time, you start to get when is the peak performance of a particular technology. The goal is to try for core areas of your product, you want to be in that sweet spot as far as the maximum maturity of that. So a different way of looking at that is the bathtub curve. And the bathtub curve is just it's actually the derivative of this previous curve here. But the bathtub curve here is the risk of something going bad. So on this axis, Y is the failure rate. So you have a low or a high failure rate. And then early on, there's again this high failure rate. So this is very common in hardware. Its components aren't quite right. They call it infant mortality. And over time, near the very end, you're trying to squeeze the life out of investment. This could be something that may be a very old Oracle application or something even older. We even have clients that are running COBOL and AS400s, so you can be on the far right side. That's when the risk goes up even higher. There's security risks, but there's also high failure risks. The idea is aiming for that sweet spot for most of your technology. When you buy, remember that if you're an early adopter or something, and you might want to be in some cases, but those innovators, if you're an innovator as a buyer, you're going to find all those bugs first. So this is similar to that adoption curve, but it's from an audience or from a buying perspective. So your goal is to be that early majority, late majority. Let me pause right there. How many of you feel that you have stuff that's too late in the technology curve, going back to this one? Can be by show of hands. Who has stuff
Meaning
that
you've got equipment that likely should be replaced with newer equipment.
And it could be software too, not just equipment.
Thrift. Stephen responded, yeah, we're doing it. Getting the most out of that equipment and out of the software that you can.
Yeah, at some point it's going to cost you more. The failure is going to kill you, the cost of recovery. How many of you are on the early side, feel that you have some stuff in your environment that's just too risky, or you've had to remove it from your environment? And it could be a new service, it may just not be a new component. Anybody too far on the left side? All right, good. You guys are all safe. You're on the sweet zone, except for some of you that are squeezing some stuff end of life. All right. Again, a very common one, just something to remind your team. You'll have some younger folks, some eager folks, and you do want to adopt in some cases, but just keep in mind if you are going to be adopting new technology, just be careful how early you are in the adoption cycle. You may be an early adopter. The risk has gone down quite a bit. When you are looking at buying something, try to look at the overall size of the company. that you're buying, you'd like to see it in the market a good 4 or 5 years. You'd like to see if you go into LinkedIn, they have at least 20 to 40 engineers, if you can figure that out. That really reduces the risk of something failing. If it's been around 5 or 10 years, you're probably in this situation here. If the company has been around longer, you're here. So think of that when you're buying software or buying services that may sit on top of AWS or Azure. Using commodity hardware, this is another one. Most of you are already doing this today, but some of you, if your company's older than 10 years old, you may not be doing this today. And we're going to explain the term goldfish versus thoroughbreds. So the idea here is just using commodity hardware, typically just focus on the need and not the additional value add. So in most cases on hardware, cheaper is going to be better most of the time. And you're typically not going to get that extra squeeze out of that. So if if all your environment is in Azure, AWS, GCP, you're really not going to have too much of a choice. But if you have lifted and shifted from your current environment, you may be using some dedicated equivalents that are the cloud version of what your on-prem environment there. So try to focus on from the compute, storage, and network, getting the maximum amount for the least amount of cost. So this was how Google started out. They were the first in the Silicon Valley to really do this. They weren't buying from IBM or Dell or even HP, even though HP was just down the road. They wanted the most bare bones stripped down boxes. When we were at eBay and PayPal, we were not in that environment. We were still buying from these vendors and needed to switch to this approach here. The focus there's optimizing for spend. Don't fall for the vendor sales pitch. Many of you may not, are probably not in that environment there. But just focus on the vanilla version of whatever's available or your cloud provider. So when you don't do that, you're at risk of lock-in because if it's more unique, it's going to be very unique support. The idea there is to avoid the lock-in risk in that case and buy small as you can and only what is needed. Don't overbuy. And if your environment's in Azure, AWS, most of you are in that situation. So the term goldfish, not thoroughbreds. The idea is, let's say you have a pet goldfish and you also have a pet thoroughbred. Thoroughbred average price is, I assume, 10,000 or more. Goldfish, if your goldfish dies, you'll just more likely, you may have a sad little funeral, but you'll just go out and buy a new one. So the idea is to replace that and only buy as many items as you need. So the idea is repeatable, incremental things. They're just much easier if something fails to replace it. And it's also easier to buy. You're buying in much smaller items and the failure rate is much better. So not just infrastructure, but also application. In infrastructure, it's a smaller failure domain. You're going to get better price performance, which we'll walk you through, and you can better optimize your cost as you scale up. For applications, the idea is as small a deployment as possible. Some of you may be deploying as far as just at a Windows server level, at application server level. Some of you may be at the container level. Some of you may be doing ephemeral compute like Lambdas. The idea there is it's just much smaller risk, lower cost of deployment and development. So just by a quick question here, how many of you are deploying today in containers or smaller? Very good. See Michael, show of hands there. A question for Michael, what percent of your environment is in containers? Is all of your primary application or just some newer stuff?
You know what? I am not very familiar with that, but I'm pretty sure it's all of our stuff is in containers. Yeah.
Very good. And did you start out from scratch in containers or did you go through a big exercise moving to containers?
So by the time I got here, everything was in containers.
Very good. Well, thank those people that are still there that did that work. If it's an older company, that's typically a big hurdle, just learning how to work with containers and manage those clusters, even though there are some nice services there. There's definitely a learning curve. So that's a good sign if you can get to that point. So to walk you through that, the idea is that as you scale up, it's much harder to deploy that. It's going to be much more expensive, and you're more likely to have underutilized components because you've typically paid up front and somebody is paying for that unused capacity in the rare times that you need it. That's the reason it's risky here. One of the curves that you'll see is Dole's law. The idea here is trying to avoid being in a situation where you need to scale up. This is common at your data layer, at your database layer, but the cost per processor, as you add more processors, goes up. But the computing power per processor typically goes down because there's more overhead required. So if you look at the price lists in AWS or Azure, you'll see generally the prices are fairly linear until you get up to the higher level, and that cost does go up quite a bit more. It's nice to have if you are in a situation where you need to scale up quickly, but you do not want to rely on that. You want to design for scaling out as much as possible. And longer term, the cost will get you too. So only use that scale up in the short term. In shorter lead time, just easier to provision, lower service cost. And over time, you can start phasing that stuff out. All right, so we mentioned this one, scale out versus not up. Don't rely on those bigger systems. Always break up where possible into your smaller systems. It's much easier to scale cheaper servers horizontally than it is to scale a large system vertically. Even though it may look easy as you go into your consoles and Azure and AWS just to upgrade and move from one to the other, you still might need to do a move from one size compute to another size compute. So many of our customers in the past have failed from this. These three examples will show you they're a bit dated, but our founders helped with these folks early in their environment. So iTunes, it tipped over early in holiday season in really their first three holiday seasons. They kept getting more and more demand because they were using a shared single database. Over time, they had to shard that and spread that out over time. Salesforce, when they were first creating their environment back in the 2000s, they were built right on Sun. The history there was Salesforce was ex-Oracle. Oracle and Sun were basically partners, if not, there's a tight ownership there that was tied very heavily to very expensive hardware. Even their biggest systems couldn't scale up. Intuit had the same thing. Their failure was all tied to a single enterprise storage device that was shared among databases. That led to a 3-day outage. Most of you are hopefully past that situation. These are all very, very large clients, but they were showing very, very large growth. And their risk was a very big shared expensive component did fail. Even though it had a low probability of failure, it had a very big blast radius. So just keep these in mind if you're in a situation like that. So again, scale out, not up. Because you get increased availability, you have a smaller blast radius. If one of them fails, it's only one nth of the customers. If one of them fails, it's also much easier to grow. So it helps with scalability as well to add that. And as part of that, you want to design for elastic scaling. That's one of the advantages of moving to containers or ephemeral compute over having just dedicated storage, because you can easily expand and contract. Otherwise, you have humans spinning up extra servers and turning off those servers. So it's much easier to do that. If you're not, you're going to over provision, you're going to buy more, or you'll under provision. So in most of our clients, we see a mix of these where you need to have some dedicated compute because it's the lowest cost per compute. When you have steady demand, when you have uneven demand, it's much easier to scale up and scale down. So by show of hands, are any of you today actively monitoring your spend in Azure or AWS? Or responsible for this? Good. You've got two there, and I know Christopher's company is fairly small. The more that you own stock in the company, the more that you're going to take care of this. Ultimately, we want each team, each small autonomous team that we talk about, to understand this spend. We don't like to see some other infrastructure team only focused on this and just sending reports that nag teams on this. We'd like for each team to really understand their spend and understand where are the cost drivers for all the way down from the data layer to the application layer and even some layers in between. Now, we don't expect all teams to understand all the components, but at least the application layer and the data storage layer, we'd like to see each team understand that and understand their cost drivers and ultimately be accountable for their costs. Next principle, isolate faults. This is going to be a bit of a repeat of our last session of our cubes, but just a very quick reminder. Yeah, Sharma, good point. Yep, you have the leads report out on a monthly basis. Very good. Yeah, and once the leads do that, their team members will they'll start absorbing those concepts within the team. So good work there. So isolating faults, the idea here is keeping things in their own swim lanes, or pods, or we call fault isolation zones. So the idea is one thing fails, others don't go down. So x-axis from our availability cube, this is redundancy. So the idea here is one item fails, something is there to immediately pick it up, whether it's the application layer, the data layer. This also includes data centers. So the idea here is if one data center goes down, you can roll over to another data center. That is what we consider an x-axis redundancy there, because you have a backup in the event of a disaster or failover. And the idea there is we want a minimum of 2 copies. We're going to walk through this math in a bit. The y-axis, this is the functional splits. And in this case, you want to fault isolate this. So the e-commerce example here on the right is the landing page. Login is a separate service from the shopping cart, from the buy again, from the search engine, from the promotions engine, from the checkout. So if any one thing fails, you can still keep the customer experience. You may lose some transactions, but you may retain that customer. And the idea there is that one thing goes down, it doesn't bring down the entire page. User hits refresh, there's a good chance that a redundant component there will pick up that service and keep running again. So it's a much better situation than the entire page not working. Same thing applies in your B2B software. You'll have different modules in there, and you want to separate these services out so that a retry can quickly pick up the service again. And then z-axis, this is typically sharding your customers, usually by geography. That's the most common way, but you may do another combination within a geography of further sharding within a geography, and we'll show you why that's important to have multiple shards even within a same geographic region. Doing this properly, it's going to improve scalability and availability. Some part fails, something else is there to pick it up and to fail over, but also scalability. You're only investing in those areas that need it. It's unlikely that the entire stack needs it. It's unlikely that all the customers need that extra capacity. You get to invest only where it's needed. So that's why we like the cube concept. Another thing to keep in mind, and this is more over time, if you've done more of a lift and shift environment, where you start to commingle a lot of stuff in the same environment. So we like to see within your particular subnets to have just dedicated services there. If not, you're going to get some crosstalk that increases the failure within a particular zone. The other thing we don't like to see is cross data center calls. And this is something we see in a lot of clients. So the example here would be you might have a primary relational database in one availability zone, but you might have multiple application servers across 2 availability zones within that same region. When you make a cross data center call, remember any call that's in this data center calling a primary database in this one is going to have multiple hops. So it's going to have a higher failure rate than others though. So if possible, you want to try to minimize those hops. And anytime cross data center calls, you're increasing the probability of failure for both data centers when this happens. So keep this in mind when you're deploying across availability zones, even within a single region. Avoid cross data center calls. Most of this is going to be taken care of you if you're doing Azure AWS. Hopefully your infrastructure teams are guiding you on this. But if possible, you want to have separate firewalls and load balancers, and then within, say, a particular zone or region, and then within the application servers, switch, compute, and storage. Again, a lot of this is going to be hidden from you when you provision in the cloud. But if you can understand the reasons why behind it, this is generally what's the cost-effective way to have the maximum availability and scalability. We talked about when you're having to make these calls to an external service, you want to avoid synchronous calls or move more towards asynchronous calls. And we'll repeat this again a bit later to try to have a fire and forget within these different regions. So this is one we'll cover that some of you may not have seen before, which is how to design for multiple active sites. And before we get into this one, are any of you today, and I think when we asked this question last week, none of you are operating in multiple, for example, regions in AWS or Azure or GCP. But by show of hands, are any of you running active in multiple regions today? Do any of you expect to run in multiple active regions in the next 2 or 3 years? for your environment. And I can understand in your situation, you may not be. So no and no. Okay. Well, we want to walk you through why this is important. And hopefully you get to the situation that your growth is that you need to be in multiple regions. But we want to avoid single points of failure. And the phrase is one is none, two is two, because everything over the long run will fail. This even includes availability zones within big regions within your data centers. N is just enough, but it's a single point of failure. And if it fails over, if you have N plus one, you can fail over, but now it's a single point of failure and it might have twice the load of the previous one. When you get to N plus two, that allows also offline patching in the situation and DR at the same time. This is why we like N plus two. When you do it, again, no cross data center calls, as we mentioned, because that increases the probability of failure, but also means each data center is really operating independently. Now, there'll be something in your environment where you have to share some data, probably some user data, but that should be passed along asynchronously in a way. So you'll need to do some design to design for this, but there are some real benefits of getting to N plus two, or what we call 3 data centers. So we're going to build up to this. This is the way we used to do it. This is an active-active. What we did, for example, for LDAP, the old way you would have, an active and then a failover. So all reads and writes would go to a primary and you would fail over. So when that would happen, though, there would be an outage because you had to fail over and then point the traffic to the new one. Okay. So there's no scale here because you have to pay for all that extra cost in your failover region. One of the first splits was just to separate your reads and writes. We talked about read and write splits before in x-axis scaling. The idea here is that you have a primary that does the writes, all the rest are the reads, and you use replication there. So then you can quickly fail over to the other one though. Some of your database systems will take care of this for you. They're managing all this for you. But the idea here is that you don't have a single point of failure for your reads, and it's a smaller outage time here. So this is just separating reads and writes. You'll probably use a feature from a managed database service provider to do this, or one that's tightly coupled to the storage layer to the database layer. In this situation, if you're managing this yourself, you have 2 data centers in different regions. The idea here is you're pinning users to one, and then you fail them over to another one. So the idea here is you're going to have to bring people over. So if you have all your customers in one, moving over to 2, and you're going to need extra capacity in your second data center because you're going to have all these users there. So keep that in mind. You're going to have a lot more demand in that second scenario. Let's walk you through the difference between 2 data centers versus 3 data centers. And the math here is interesting. If you have 2 data centers, you're going to need, for the same traffic, 220% to support all the traffic, but have enough capacity to fail over. If you have 3 data centers, you only need 165% of your current capacity. Okay. This isn't intuitive for most folks, but we're going to walk you through what's going on here. So the idea here is you split the backups. A is primaried in one region, and then you have half of those backed up to a different region and half backed up to another. So to do this easily with out-of-the-box technologies from your database vendors, or like RDS from AWS, you'll have to split those pods up. So you might have 1/3 of your customers here, but those are split, say, in half. Half of them are backed up here, half are backed up over here. You repeat the pattern in data center B and data center D. And that way you only need half the capacity because of the probability of failure in either one of those. Okay. On the server capacity, you're only needing half of it. And then the data, you'll need a bit more for failover. And this is the table here that kind of walks you through the difference between having a single site, 2 sites with a hot and a cold, 2 sites with them both being active, where you're splitting the traffic, and then 3 sites all live, where you get this math behind it here. So it's a neat way to save costs. So if you're going to ever consider going from 1 data center to 2 data centers, actually designed for 3 data centers, and particularly 3 regions, not 3 data centers within a region. Okay. Again, I know most of you are not in this situation today. You may not be for 2 years, but keep this in the back of your mind of why it's important to do this, and why it's important to have infrastructure as code, because this makes this a lot easier versus having your team do this for you. Again, something We found out the hard way at our time at eBay and PayPal because we were buying these data centers. And we had to think through this because there's a lot of infrastructure in buying a data center and buying everything that's needed inside there. So now that we live in the world of cloud computing and infrastructure as service, this is a lot easier for us today. So you can reap the benefits of all of those painful failures that folks at Google, Amazon, and others have had of learning this. I hope all of you get to that point where you get to 3 data centers in 3 regions.
Philip, it's, I think, a good to ask the question. The math is not intuitive. Does it make sense to you why 3 sites or 3 regions is less expensive for the overall environment costs?
Show of hands, is everybody? Yep. Okay.
Christopher's struggling. That's all right.
Yep. No problem. So the idea here is in a single site, right? You've got, let's say you've got 100 users today and you've got a certain size box for your app server and your database there. So this is your cost for a single site and there is no failover in this scenario. So if you have a backup site, and this doesn't matter if it's within another availability zone or the region, to be able to fail over quickly, you need to pay for a second box. And so that's the 200% servers. You're going to pay for a separate network connection. You're going to need a second one for the database server itself and also the servers. So you need to pay for 200%. But when it's cold, you're not using that other site at all, right? Now, when you go to 2 sites that are live, and in this case, you are splitting your traffic into 2 sites, if you want to be able to fail over quickly, you still need to buy twice that capacity in the event one fails over, and you want to handle all that traffic and all that storage for one environment going down. That's this 200% number here. So you're spending the same, but you get much higher availability and you're getting much higher utilization in the situation here. So if you're going to spend the money for hot cold, you might as well go to live live. Now, you'll probably get different pricing when you buy this from AWS. The reason with 3 sites that you don't need as much capacity is because you're actually making the bet that 2 of the other places are not going to fail. Okay. So if any one of them fails, you only need enough capacity if one of them fails here in this case. So you have the 100% here, and the remainder is half of B and half of C. So this is you only need 50% total here of the total amount if you have 3 environments here if you split it 3 ways. So that's where the math comes in, is you're not having to back up all of B and all of C in the situation.
The server, storage, capacity, power consumption, all of it is
the entire stack. Yeah.
It's effectively lower because you're not serving as much traffic all the way through in each site.
Exactly. And if you're thinking how to do this, you will have to split A, B, and C also probably into subpods so that you can easily have half of A back up to C and have the other half of A back up to B, because that's not out of the box for your backup software from RDS or from others though. So you'll probably need to have multiple pods in each location to enable this, but you just won't configure all of them the same. You'll have half backing up to one, half backing up to the other. Okay. All right. Very good. The other advantage, again, is you can roll things out. If you roll out a new feature and it breaks, which features do, it's only going to impact 1/3 of your users. So when you start getting to blue-green deployments, this is really the approach that you're doing here. We've even seen a lot of our clients do rings or even within a particular region, and they will actually roll out to an even smaller segment within one so that the blast radius is smaller. So even within A in this environment, they'll have 2 or 3 stages of how they deploy features, and they wait for several days or so before they say, okay, now roll it out to the rest of your pods throughout the rest of your environments that you're located in. But once you've done it once or twice, it makes it a lot easier to do that. Which leads us to build small, release small, fail fast. When you first are creating your product, you're probably going to create a fairly large monolith, but over time, your risk profile gets larger. And so we want you to release smaller items, focus on crawl, walk, run. You want to get the results as fast as you can. Taking a long time to do one thing perfectly in most situations, particularly competitive market, is not as good as taking less time to do a lot of things well. And there's some scenarios, some particular places you want to win in market, but usually if you wait for perfection, it's going to slow time to market. That allows competitors to catch up and surpass you. You want to get in that habit of releasing small and moving forward quickly, because the longer you wait, you're compounding the risk of something going wrong. So the way we show this is the cone of uncertainty. So let's say you start out with, we have a very set of specific features or capabilities today. 2 years from now, we don't know the outcomes of what those are going to be. There's a wide range of what those could be. And this is just the degree of precision. On the top end, think of this as a positive outcome. You're making lots of money, got a lot of customers. At the bottom end is you have launched something that features that customers do not want. And the market has changed because whatever you wanted today is going to change in the future. So the idea is every 3 to 6 months to look at your OKRs and reset. That target that was 3 months ago is now getting smaller and more refined. It's adjusting again as you're adjusting to market conditions. The circle is getting smaller and smaller and smaller. So your uncertainty is getting a lot better as you hit that target mark, though. And so in this case, you're looking at 5 or 6 chances to correct course versus if you wait for perfection, you only have 1 or 2 chances, and the likelihood of you hitting that target is very small. Your path is going to change every 3 to 6 months based on what you find, what you learn in your environment, how the market responds. So that's why I want you to focus on outcomes, and your methodology should be approaching this. So this argues for agile over waterfall in this situation. Using principles, your architectural principles, don't let waterfall detract you from this. And there's maybe other parts of your company that lend themselves more to waterfall. For example, you may be in a B2B sales cycle where you've got big deals that take a year to land, maybe 2 years to land, and you're filling out a big RFP, and the sales team is hearing, if you get these 2 or 3 features, we're going to win this business. And those are big bets. And that's something that most of you are going to struggle with as you're growing your team to do that. You're going to want to keep iterating away, and that's the struggle you're going to have in the B2B space. In the B2C space, it's similar. If you have investors that are making big bets or executives that are making big bets, it's a higher risk. Keep in mind this cone of uncertainty of those outputs. So it's better to build small, release small, fail fast. You're going to have a much better chance of hitting your target. Buy when non-core. We see this a lot, particularly for software as a service companies that like to hire engineers that were designed to build things. But in most situations, you're going to buy a lot of stuff, and you're going to want to buy stuff because you're going to want to only spend that engineering dollars, typically your most expensive resources, on things that will give you a competitive advantage. There's so many things that have been built by others that it's very hard to justify building your own components here. Keep in mind, just in a lot of things that we do, a lot of engineers will build stuff that don't offer a competitive differentiation. It costs more, steals focus away from gaining customers. And again, it's not aligned with your outcomes or skills. The person that built it typically leaves. Whenever your team is wanting to build something, take them through this simple decision tree. So first off, is it strategic? If no, then buy it. If it's not strategic, are you the best ones to build it? If no, then you buy it. Are there competing products in the market? If no, if there are no competing products, then you can consider it. Can we support it long term? In that case, if you can support it long term, you actually should build it. And then lastly, can you do it cheaper than others? So you have to say yes, all these questions here before you need to build it yourself. There's very few engineering teams that can answer yes to all these. So just keep this in mind when you see common services or things that are available. You'll want to buy things in most cases. When you do buy things, just keep in mind you're going to be at the mercy of their availability. There will be situations where you'll buy a service to get up and running, and then over time, you may find that you're tightly coupled to that service and it's not able to release features fast enough for you, or you're at their mercy. If they're down, you're down. So there may be some situations where you pull this out from a service that you have bought or rented, say from AWS or a third party.
My favorite example of this was years and years ago. 3 engineers came to me with a small tool that they'd built for, we were designing and building pacemakers and the software that runs them. They built something they were very excited about it. It was the equivalent of an FTP server. It moved the file from here to there. They were so excited about it, wanted to get it into production, and we didn't have this chart, but effectively, were they the best to build it? No. Do we want to maintain an FTP server long term? No. So we brought in a very small open source commercial package that did exactly the same thing, and effectively lost about 3 weeks worth of development effort on something that really didn't matter.
Now, on the converse side, we do a lot of due diligence for companies, and we've done several that are basically spin outs of somebody that decided to build something internally and realized it didn't make sense for them to continue to do that. It was a commercially viable product. And so they spun that out and spun up that team. So if you do find something exciting and you've been pretty innovative, think about spinning that out if it's something that could scale. I am curious if any of you on the call are in that situation where your company started from a spin out of something else that was built at another company. And I would expect half of you have been, because that's where these opportunities come from. Just think through that where you are in that buy versus build. But longer term, you're going to want to get good at buying software. And a lot of engineering firms are not good at buying software. So we're going to skip through stateless systems due to time. We covered state quite a bit in our last one with the state cube. So again, the idea there is you want to be stateless as much as possible because it increases availability. There's fewer things that can fail, and it's also lower cost. There's less things that you have to process. There's less data. You want to reduce the size, and it'll help you with the probability of failure. And when we talk about state, there's session state, application state, and connection state. Where possible, you want to move towards a stateless solution. Again, our state cube, just thinking of it of a few different dimensions. One is how big is this of something you're trying to save the state of. The y-axis is the domains or logical separation. And then the z is where are you storing that state? In this case, a cache. Was it within the app, was the most expensive, highest risk one versus pushing all the way to the browser as a cookie or no state? That's where you want to be. So where possible, design for stateless. Now, as you grow, as you start out, you're going to have state at some point, but you want to minimize this. The more state you store, the larger it's going to increase your probability of failure and your cost. We walked through these examples before. We mentioned of a shopping cart, payment. Just one quick example as a reminder for you guys to think of a payment example. We had one particular company that we worked with that what they do is they do the e-commerce at a big concert. A lot of times these concerts are now being held in venues that are very remote and don't have a great network connection. They have to be able to take credit card payments with an unreliable network connection. So they've actually designed a way to basically detect fraud without talking back to the server, because they've done the math to realize that most people that can afford to get into this venue, their credit cards are going to be good, and they may not settle until later, until the next day. And so any amount of fraud is completely offset by the amount of revenue they're going to make versus had they turned down that sale at that point in time. So just it helped them get very creative and understand their payment challenges. And they were forced to just due to their market. So there are ways to solve these problems creatively. In this example, there were different ways that they mitigated their payment risk. So just another way to remember how to think of a stateless solution. I think in a workflow is your most challenging one for state. We're going to go through these two pretty quickly also. These are just reinforcing the concepts that we've covered in the availability risk model and also in the patterns and anti-patterns. It's microservices for breadth, libraries for depth. Services to go broad for different functionality, but don't do those deep call chains because it's going to increase the failure. And anti-patterns, all the ones we covered last week, will basically increase your probability of failure. And we want to use libraries for depth when you need to make those deep calls. There's a lot of advantages to microservices. You can deploy independently, team zone them. They can be fault isolated. They can scale independently. But if done wrong, then they're going to have lower response times. It's going to have too many services. Velocity decreases. It's going to lower availability. Avoid, in this case, this is a fuse, a service fuse, two services calling the same service. It's better to deploy them in libraries attached to that same box. because you've decreased that probability of failure. Remember here, it's the probability of all three of these here being up at the same time. That's and any one of them fails, that's going to break. Where in this one, you only need to have, you've just dramatically lowered your probability of failure here. That's the reasons for deploying libraries instead of services. And related to that is asynchronous design. Always call asynchronous whenever possible, and only do synchronous when absolutely necessary. Just keep that in mind when you're talking to your team. Fight as hard as possible for async versus synchronous communication. And when explaining this to others, synchronous is just like a phone call. Just think how productive you are on the phone. It's very hard to multitask, at least it is for me. And asynchronous is more like chat. You can have multiple conversations going at the same time. Just keep those synchronous phone calls when you need to talk to someone when you really need it. When you're talking to your loved ones, talking to family, an important situation, pick up the phone, use that. Otherwise, have those asynchronous calls. So try to do asynchronous whenever possible. Just keep that as a principle for your team. Act asynchronously whenever possible. And rounding this out, automation over people, just build everything to be automated. Never rely on a human when a robot could do something. It's just going to be cheaper long term. It can work at night. You're not likely to make the mistakes. It's also very good for auditing and compliance. If you don't have that, you have humans, you're looking at manual logs. The more you automate, that's much easier to deal with your audits and compliance. And it frees up humans to focus on innovation and building things. How many of you feel like you're missing automation today, either in your infrastructure deployments or in your automated testing? A show of hands. So, Christopher, is that on the infrastructure side or the QA side? QA side, very good. Yeah, that's the most common one. When we get into Agile in 2 weeks, that's going to be your biggest key to doing Agile. You need automated testing. Otherwise, it's going to just get harder and harder to do that. We are almost done. Design for rollback. This is one that most folks are thinking through this, but you want to be able to roll back any release, but always have the ability to roll back code and the database. When we do due diligence, we're always looking for how well can someone recover from rolling back a database change. You want to be able to roll back versus fix forward. Yep, going through this right now. Just a question for Stephen. Do you have a particular rule or process for database changes to help minimize this?
We don't. It's not standard across. And so exactly what we found is that more than half of our incidents are resolved with fix forward instead of rollbacks, which is certainly a problem. And yeah, database changes and database migrations is definitely a big part of that.
Yeah. So that's another of the items that we like to see in the definition of done in Agile is it's not done until it's got a rollback in there. The more you have that just as a default decision, that's very helpful. I meant to add in here, we have the simple rules for database schema changes, but we can point you to that. There's a particular way, and it's typically the database schema changes that get people in trouble, is not thinking through that and splitting that out over 2 or 3 releases in order to safely make a database schema change and a code change. Being able to tighten that window and release quickly, it makes it easier to safely make a database change, application change, and then final database cleanup. We've all been burned. That's true.
Yeah.
There's what's this phrase
Chris
from Top Goes on? There's old pilots and bold pilots, but there's no old bold pilots. Yeah. So exactly. You don't want to take off in a plane and not be able to land it. So just keep that in mind with your team. You'll eventually learn this
in production.
Yes, we all learn this. We all pay for education one way or another. We all learn this lesson. All right. So landing out today, design for scale. Just something to keep in mind that we like to think about is designing for 20x scale, implement for 5x, deploy for 20. So this is more of a table to think through, but you might spend a lot of time thinking of how will we scale our architecture to 20 times. And this is the design concept. You're not actually going to implement that in the code or deploy that in your environment. There's a lot of intellectual cost up front here to design for scale, but you've not spent a lot of engineering time. You've not spent any money on assets. Your total cost is very low. But to implement, now you've bringing in your teams, you've got 10 or 100 engineers, and so your cost is higher. And then ultimately deploy, this is when you're actually provisioning the infrastructure for that. The total cost, though, is again very low if you design for scale versus doing it later. Always think of scale ahead of time as soon as you can, as early as possible. Set aside a time at least once a year, if not twice a year, to think through where we need to scale. When we get into operations next week, we'll get you through talking about a more consistent cadence. That leads us into next week's session, and we're going to cover monitoring and operations. So really how to run the business. We're going to add quite a few new things that you guys might not have seen before when you've worked with us about just how to run things 24/7 with a small team and embedding these capabilities into your teams. Please come back next week and bring in more of your team for operations. This is something we'd like all of your engineering teams to understand, these concepts, not just the principles. And then we'll move into Agile and Waterfall. For most of you, if you need to go, you can, but Doug and I will stay on for any questions that may have come up during the time today.
Yes,
you bet.
Sharma, the presentation slides will be, my intent is to get this video processed by tomorrow. It'll be up by Saturday or Sunday, and we include this deck as a PDF. I'll make certain that you've got the links.
Thank you.
All right. Thank you, everyone.